Next, angle between two intersecting circles. Angle between two intersecting circles is the angle between the tangents at the point of intersection of the two circles. So this is the first circle, this is the second circle. Let P be the point of intersection of the two given circles, 1 and 2. So there are 2 points of intersection, right? I am taking only one, right? P. Let PT1 and PT2 be the tangents at P to the circle 1 and 2. So this one PT1 for the second circle and PT2 for the first circle, tangents. The angle between PT1 and PT2 is the angle between the two circles 1 and 2, right? Angle T1 PT2 is the angle between 1 and 2. Note, if two circles intersect at P and Q, then the angle between the two circles at P and Q are equal, right? Suppose if it is Q, if you are taking the other point of intersection, then this is also equal, right? So next result, if C1 and C2 are centers and R1 R2 are the radius of the given two circles, then the distance between two centers small d, which is equal to C1 C2, and theta be the angle between the circles, then cos theta is equal to d square minus r1 square minus r2 square by 2 r1 r2, right? So angle between the two circles is given by cos theta is equal to the d, that is the distance between the centers of the two circles square minus first circle radius square plus second circle radius square by 2 into first circle radius into second circle radius, right? We'll see the proof. Let P be the point of intersection of given two circles, right? And draw the tangents PT1 and PT2 at P. Join C1 and C2. Let PT1 and PT2 intersect the line joining the centers of the two circles C1 C2 at Q and R respectively, right? This is Q, this is R. Join C1P and C2P. Clearly C1P is the radius of the first circle R1 and C2P is the radius of the second circle R2, right? R1, this is R2. Given angle between the circle is theta. So that is angle T1P T2, which is equal to angle QPR, which is equal to theta, right? QPR, right? Because T1P T2 and QPR are equal angles, right? Point of intersection of the two lines, right? PT1 and PT2, the extension QT1 and RT2, right? So these two angles are opposite angles, therefore they are equal. Now angle RPC1, which is equal to QPC2, is equal to 90 degree. RPC1, because RP, that is RT2, RPT2 is the tangent line, C1P is the radial line, right? Radial line always perpendicular to tangent line, that is why angle RPC1. Similarly for the second circle, angle QPC2, which is equal to 90 degree, right? That is equation number 2. Now angle RPC2 is equal to angle QPC2, right? QPC2, right? Minus big angle minus the small angle QPR, right? So that is equal to 90 minus theta by using 1 and 2, because QPC2 is equal to 90 from 2 minus QPR is theta minus theta. That is equation number 3. Now angle C1PC2, which is equal to angle C1PC2, which is equal to angle RPC1 plus angle RPC2, sum of the two angles, right? That is equal to 90 plus 90 minus theta, right? By using 2 and 3, so you will get angle C1PC2 is equal to 180 minus theta, right? That is equation number 4. We know that in a triangle ABC, sides ABC, sides distance length ABC, small ABC, right? ABC is a triangle, so opposite to A, vertex A, the side length is small a. similarly small b small c, right? So this angle at vertex, let the angle be a, similarly let the vertex b, the angle is b, and the angle is c at the vertex c. We know the formula cos A is equal to b square plus c square minus a square by 2bc. So we are using the triangle C1P C2, C1P C2. So this is the triangle, right? So this is R1, this is R2, this is the angle 180 minus theta, right? So we are going to use this formula, right? So cos 180 minus theta is equal to C1P square plus C2P square minus C1 C2 the whole square divided by 2 C1P into C2P. That is R1 square plus R2 square minus C1 C2 the whole square by 2 R1 R2. But C1 C2 the distance we already know, that is given small d, right? So cos 180 minus theta is minus cos theta, same ratio but sign will differ. 180 minus theta is the second quadrant, sign only positive, cos is negative. That is why minus cos theta, which is equal to R1 square plus R2 square minus d square by 2 R1 R2, right? So therefore cos theta is equal to multiplying by minus, so you will get d square minus R1 square minus R2 square by 2 R1 plus R2, which is to be proved. Thanks.